Welcome to a new test and teardown video. This time it's a Radiometer Electronic Galvanometer GVM30. So this design is from about 1970, so it's actually quite old. It's very, very heavy. I think this is a casted aluminium case. So the low and high is shielded PL259 connectors, and yeah, we got some outputs for recorder. And this thing can actually measure all the way from 30 picoamps to 300 microamps. Of course, it can also measure volts, and I think this is 1 millivolt and to 300 volts, and also ohms to 300 mega ohms. So it's actually quite impressive. But the lowest ohm is 1 kilo ohm full range. So this is not a low ohm meter, but more or less a high ohm meter. There's a quite beautiful state this one is in. When it comes to the front panel and all that, it looks really, really nice. I have just been cleaning it up a little bit. Here there was a label from the company that owned this one, and it looks really, really bad down there, but I think you could repaint this. And this operates off a 9-volt battery. And see, there is some sort of response. Why is it going down? Yeah, so there's definitely something going on here when I push this. So there's a battery inside, a 9-volt battery, and it has probably been in here for the last 20 years, so there's no other way than open this and see how the battery is. So how do I do that? Okay, here is okay, 92. So since 92, they forgot the battery, and there's another screw here. Okay, let's have a look then. And we are inside. It was just to unscrew the two here at the bottom. And again, I've said this a million times, folks. Always take out batteries from equipment you don't plan to use anytime soon. Because there is a high risk you forget it. Look at this white goop. We got all colors of bad here. What is that? Blue acid corrosion, and here, look at that. How bad is that? There's a lot of this. And what is this? A loose washer? Where's that coming from? Well, oh my god, this is bad. So it is definitely time to go and do a little washy. Clean up everything. So I wonder if I can just unscrew this. Yep. Wow, look at that. So there's even some sort of a shield. Also because I don't think, no, this center voltage is not connected to anything. But other than this, it is really a beautiful battery system, or battery holder they have made. Look at the way that everything here is made. So this is this piece. So it's flexible. Yeah, this is the hinge. I mean, this is really, really good because there isn't really a lot of moving parts or anything that can cause loose connection. Because this part is the part that is touching this battery, and it is also this part that is touching the other battery. So there is no way to cause loose connections. I mean, other than here. Here we got this problem. So here we should have, yeah, this wire should have been soldered directly to, okay, look what they did. They soldered this joint and soldered it here. Oh, they are not beginners, those guys. They don't want loose connections, obviously. But anyway, I need to clean everything here. I will be back. God, this is so bad. When somebody figures out how to design batteries that can't do this, I think they're gonna rule the world. They're gonna take all the money there is in batteries, because this is a pain in the butt. Damn it. Just for the record, here is the date code 0694. So that is also some years ago, I must say. Ooh, that was a lot of cleaning. See, all the white acid, dust and funny stuff went away, and it took the paint with it. And so the battery compartment here is now completely cleaned. See, I still got a little bit in there, but it's difficult to get in between here. But I think I took most of it away, but it's a little bit down in there, but still going to work anyway. So this is as clean as I could possibly make it without pulling it completely to pieces. I also put in some alcohol in here and all over the place, and cleaned it with brushes and compressed air and all that, so it should be really, really nice and dry and clean now. But I'm a little bit worried if some of this white powder came in here, so I think I need to disassemble the meter itself and have a look. So I think it's only 4 screws, and then I will be able to look more inside. And we're inside, and yes, or no, should I probably say, look at that. This looks like a contact, because I thought I heard something loose in there. Oh no. But there's a really nice rubber gasket in here, so it should be really nice and clean. And here's actually a little surprise in the first second. Look at that. So this is a trimmer capacitor, and this is the 0. Really? So what this is doing, it's actually an AC chopper, right? Otherwise, we wouldn't need a capacitor to zero out all the capacity in the AC circuit. So that is definitely because this is, I think this is an AC chopper. Oh, hey, look at that. What is it saying? 3.16 km or something like that, and 10.1 meg 1%. Ooh, look at that resistor down there. 100 mega 1%. Wow, that is nice. So that will be all the high mega ohms. Oh, look at the shielded cables in Teflon. Ooh, ultra low leakage stuff. Isn't that just nice? And we got red and green written in Danish. Isn't that just sexy? So there's a shielded electronics board in there with, ooh, this appeared to be some Teflon. Yep, some Teflon isolators and some stuff on this PCB. Again, shielded Teflon cables all the way on all the critical stuff. But I haven't figured out, where is this part coming from? And this looks like special plastic on the switches, because this is not how they normally look like. So what they've done is they've created some special low leakage switches, because what you see down here is the normal Pertinox PCB material, but here is some plastic super duper isolating material. And then the switches, are they also special and sexy? I don't know. That is again Pertinox and special isolation around there. Wow. I really hope this meter works. But I want to go in here and have a look. Here is a DC amplifier. It says DC amplifier. So how can it be working at DC and then we got a trimmer capacitor here? That is confusing. Maybe I should try and get some schematics and stuff and see if I can figure this out. Or I could just power this up and see what is going on here, right? Because this is my thing. Try and see if I can figure stuff out without, you know, a lot of research. Oh, we got a lot of trimmers down there as well. A little solder blob that was left there. Oh, let me see if I can figure out how to get this PCB out. Just too bad. It is not working. So this is 9 volts, about 4 or 5 milliamps. I really tried to connect everything here correctly, so I think that is done. And it is a little bit crazy. What I see, bat check, seems to be working. All right. And if it goes on, and I think this is 300 volts. Really, really stupid with the white marking here. And if you are here, you can't see where are you. So that should have been marked here on the top. But anyway, it is absolutely not working in any of the ranges or anything. So you measure is out and it just goes plus minus all the way. And I tried to short the inputs, or short it to ground here, and I get just absolutely nothing. Damn it. What are you doing? I don't know exactly what to do here because it's not working. So here we go, full. It's not responding to anything. So the amplifier is completely dead or full of this white acid fume that went all over the place. In OMC, I get the same. And no response. You see? What is this? Set 0. If it's in, dial this. No luck. Nah. We need to poke this thing to pieces. I mean, there's maybe a reason why this meter was trashed. This one was scheduled for being thrown out, right? And then I just got it. Let me see what is in this box. A DC amplifier. But it says something about output and RC. Yeah. So it has something to do with time constants, right? And this is the input low and high. I want to see more inside this thing. Wow, look at that circuit. There is nothing in here that looks like DC. This is DC amplifier, but look at that. It's full of capacitors and inductors and stuff. And trimmer capacitors. So how the heck can this be DC? I totally don't get it. But anyway. So the input goes through 100 mega ohm. And then there's a wire to another 100 mega ohm. And then there is a diode. And then there is another... all these... I don't know, man. This looks like an oscillator of some sort, right? And they really went all the way to mark those wires. And then there's another side of this transformator that goes to probably some sort of an oscillator, right? So what we see here is 2N4302 JFET and 2N4126 PNP transistors, right? And one more here, yeah. 41. Oh, this is a 24. Oh, it's not a 26. Yeah, this is 26. So those two are definitely PNPs, and this is probably an NPN. And then there's another one here. Oops, can't see that one. That is the secret transistor. And there we go. But this circuit is not working. Or there's a leak somewhere because of this white powder, this acid. Try and imagine the whole cabinet was full for like 20 years with like acid fumes that just put a tiny little layer on everything here. And we're talking about 200 mega ohm circuits with a tiny little bit of acid stuff all over the place. So of course you can imagine that this is why nothing works. Maybe nothing is broken, but it's just not working because of a leak. That is very, very possible, because what we got here is 100 mega here as well, and I don't know what. That is a very, very sexy glass resistor, and look at the windings in here. What have they done? Maybe that is some sort of a temperature compensation for some of it, right? That is a very beautiful resistor. I love it. But just too bad this is not working, and there's no way that I can take everything to pieces and clean it. I don't know. It's gonna go all over the... it's not repairable. At least not for my patience level. Ooh, what I found here. Did you see that? Yeah. Is that where this plastic thing was? Where is it? See this little plastic thinger? Right? Look what I see here. I see more of this plastic here. And what if you look at the other ones? Here is something that is moving up and down, right? And this piece is missing here. Oh, this is where it's broken. Oh, yeah, man, I found it. In here, it is broken. And the other half of the piece is down there, right? And this is, of course, going to connect some of these wires. And that is not happening. And that is why nothing is working. God damn it. That is possible to fix if you are like really, really smart and figure out how to take this little piece out in there and how to get in there. I don't know if I can do that, but it is possible, right? Get this contact out. How do we... Ooh. Yeah, so this... Oh, you can even see it now. See, it is not moving this switch down there, and this other little piece is in here. And what is that switch doing? It is the measure or set zero switch. that is not working. So yeah, so far I can't repair it. I don't know how to get in there. Yeah, that was sad, but at least we got a nice and beautiful look inside this beautiful, beautiful product with a broken switch. And I think I will take this little piece and tape here in the bottom with a little note, so somebody in the future will know exactly where to look. Yeah, that is what I think I will do. Now I can just assemble everything and be sad I was not able to fix this easy way. Look at this circuit. Wow, man, this is crazy. But here we got 5%. I bet this is just input series resistance, so it's not really affecting the measurements. But I mean, this got to have something to do with AC somehow. DC amplifier, yeah, right.